Hi, my name is Alvin Gigi, and I'm going to be giving a presentation today on data visualization. The reason I chose this topic is because for our capstone project, there is a component, a data visualization component, and I'm leading that part of the project. So I've been learning more about it as I've been doing this project. So yeah, to begin with, what is data visualization? Data visualization is the taking of a data set, which may be small, large, or somewhere in between, and creating that into a visual form that is more easily interpretable. So data visualizations can be used to support reasonings, answer questions, communicate or present ideas, inspire other data visualizations to be created, present findings in a report or in an experiment, reveal patterns in data, which is really hard to see when you have like really large data sets. And the most important purpose of data visualizations is to make decisions. They simplify data so that decisions can be made from the visualizations. Yeah, so why do we visualize data? So the human visual system is the highest bandwidth sense that we have. All the other senses are lower bandwidth, and that just means their connection to the brain is just lower. But yeah, so just a couple of definitions. Visual perception is the act of seeing a visual or an image. And cognition is the act of thinking or processing information, making comparisons, and examining relationships. So the important thing to note is that visual perception is done within the visual cortex. And the visual cortex is actually extremely fast and efficient. And the cognition is done within the cerebral cortex, which is much slower and less efficient. So data visualization actually changes our, normally we rely on cognition, but it actually shifts that balance from cognition to visual perception, which we learn is much faster and efficient. Yeah, but there are some limitations of data visualization. For example, since you're dealing with such lengthy data sets, and you're trying to convert that into simple visualization format, you get estimation and not accuracy. So you lose some complexity when you try to visualize data, and that can lead to skewed conclusions. Another limitation is that it can be biased. For example, the person creating the visualization introduces bias by they can choose certain parts of data to visualize and not other parts, which might be influenced by their bias. And they can also choose what type of visualization to use. They can choose something that they are more biased to use, which might not be the best representation of that data. Another limitation is a lack of assistance. So a visualization just exists. There's usually not something that accompanies it. So there's a lack of assistance, meaning different types of people or different groups of people can interpret the data differently because there's no one telling them how to interpret that data. And the last one is an improper design issue, meaning we're human and humans are the ones that create data visualizations. So human error can result in not following convention or using inappropriate visualization methods. Here are a couple types of data visualizations that we're familiar with. Tables use rows and columns to compare variables. But the problem with tables is that they're very numerical and they can overwhelm users. The other ones are there's a pie chart, which is divided into sections to represent parts of a whole, like we were talking about, and it makes it easier to compare sizes of each element. Line charts can show change in one or more variables or quantities over time. Bar charts are useful for comparing categorical variables. Like we can see there's chocolate, strawberry, and vanilla. Those are categorical and not numerical. Scatter plots can show the relationship between two variables, like we see with cost and weight. And heat maps are helpful in visualizing data by location. And this can be location on like a map, like the United States, or it can be a web page even, and which is really useful in UI UX design, where you can see where users' attention is mostly concentrated in. So a heat map on a web page is actually a data visualization too. And lastly, some common data visualization tools are Tableau, which is by far the most popular in industry. It has hundreds of data import options and other features, but the one downside is that non-free versions of Tableau are very expensive. The one that I'm used to using is d3.js. It is a JavaScript library for visualizing data. It has a huge number of chart options. It's free and open source, but it does require programming knowledge. So the knowledge of JavaScript, HTML, and CSS would be very helpful in using d3.js. And lastly, Google Charts is up and coming. It is very useful for embedding charts and content online. And one of the great parts of Google Charts is that it can use dynamic data. So data that is changing and updating constantly. It can use that and embed that within your web pages. But one of the limitations of that is that since it is so new, there's less support and documentation for it. Lastly, these are the references that I used. But yeah, thank you so much for listening. Yeah, thank you.